A laser message from space. Hello, world, presented by Science at NASA. Anyone who remembers dial-up internet can sympathize with the occasional plight of NASA mission controllers, waiting for images to arrive from deep space, slowly downloading line by line, can be a little like the World Wide Web of the 1990s. Patience is required. A laser beam lancing out of the sky last week could change that. On June 5, 2014, the International Space Station passed over the Table Mountain Observatory in Wrightwood, California, and beamed an HD video with the message, "Hello, world," to researchers waiting below. Unlike normal data transmissions, which are encoded in radio waves, this one came to Earth on a beam of light. It was incredible to see this magnificent beam of light arriving from our tiny payload on the space station, says Matt Abrahamson, who manages the optical payload for lasercom science at NASA's Jet Propulsion Laboratory. Better known as OPALS, the experimental laser device was launched to the space station on board a SpaceX Dragon spacecraft in the spring of 2014. Its goal is to explore the possibility of high-bandwidth space communications using optical light instead of radio waves. If successful, researchers say OPALS would be like an upgrade from dial-up to DSL, achieving data rates 10 to 1,000 times higher than current space communications. So far, so good. The entire transmission on June 5th lasted 148 seconds and achieved a maximum data rate of 50 megabits per second. It took OPALS 3.5 seconds to transmit a single copy of the Hello World video message, which would have taken more than 10 minutes using traditional downlink methods. The message was sent multiple times during the transmission. Abrahamson says the video is an homage to the first output of any standard computer program. Let's take a look at it now.
It's the story of an endless search to serve the communications needs of America.
Why the hurry?
Here is modern telegraphy at work, sending and receiving in facsimile.
This is information. May I help you?
The needs of today keeps pace with the tempo of a fast-moving age.
Because the space station whips around the Earth at 17,500 miles per hour, laser tagging a telescope on the fast-moving ground below can be tricky. To accomplish the precision tag-up, a laser at the ground station illuminated the space station. OPALS responded by sending its own 2.5-watt encoded laser signal right back in the same direction, carrying the HD video. During the 148-second transmission, OPALS maintained pointing to the ground station within 0.01 degrees, while tracking at speeds up to 1 degree per second. NASA missions collect an enormous amount of data out in space, says Abrahamson. Laser communications is a faster alternative for getting those data to the ground. With this demonstration, we're paving the way for the future of communications to and from space. Hello, world, indeed. For updates from OPALS and other paradigm-breaking projects at NASA, stay tuned to science.nasa.gov.